So we're continuing in section 3.5, and before we move on to a different topic, last time we said that implicit differentiation is about differentiating an expression in x and y, mixed expression, right? And then we assume that y is a function of x, right? And then we just differentiate. So for example, we might have something like x squared plus y squared equals xy. Okay, so in differentiating, if we assume y is a function of x, then we could write the derivative as, in this case, it's f of x squared, right? So the derivative would be 2 times your f of x, which is y, to the 1 power times dy over dx. And then this side would be the product rule, so that would be y plus xy prime. Oop, I guess I'm writing it as dy over dx. So we should be consistent. Okay, and so now I'll bring this over to this side, this over to this side, and we'll get 2x minus y is equal to, I'm going to factor out my dy over dx. It's going to be x minus 2y, it looks like, huh? And so we can write dy over dx as 2x minus y over x minus 2y. Good. Now I just wanted to note that you could treat another variable as the function. So for example, suppose we want to find dx over dy. So this is assuming that x is your function now, and y is your variable, independent variable. Okay, and so now in the same function, right, what would that be? Let's go ahead and differentiate it again down here. Now remember, x is our function instead of y, so that would be 2x times dx over dy plus, now y is just the independent variable, so that's just going to be 2y, and then we'll have dx over dy times y plus, and then x times the derivative of y, which would just be 1. Good. And now we'll bring over the dx over dy terms to one side and the other terms to the other, and we will solve. So if I factor out the dx over dy, it looks like I'm going to have 2x minus y equals x minus 2y. And so if we solve, then we get x minus 2y over 2x minus y. Good. Now, what you should be thinking to yourself is, gosh, that looked familiar. Do you see what the difference is between these two? Good. In fact, you see the thing that makes Leibniz notation so nice, this fraction notation, and that is that we could actually treat this as a little fraction. In other words, dx over dy is equal to 1 over dy over dx. Right? So, excuse me, we could have found dx over dy just by inverting or taking the reciprocal of dy over dx. Good. We're going to actually see why that's true in another aspect. It'll be a little bit different argument, but the same thing works. Okay, and now we could get even more extreme, if you like. We could say, given something like a squared x squared minus b squared y squared minus bcxy equals 0. And now pick a variable for your function and pick a variable for your independent variable. Let's say the function is b and the independent variable is y. And so we want to find db over dy. And so everything else in the expression is constant, right? And so in a squared x squared, that's all constant, so that derivative is 0. Minus, now this is going to be a product rule, and so we're going to have 2b, oops, sorry, 2b times db over dy. That's the derivative of b squared times y squared plus now b squared times the derivative of 2y, and y is our independent variable, right? Minus bc, I'm going to run out of space here, bc, and now I'm going to differentiate xy as a product rule, but x is just a constant, right? Oh, b is my function. I can't put it out there. I can put c times x out here, right? And then I would be left with b times y that I'm differentiating. And so that would be db over dy times y plus b times the derivative of y, which is 1. Good. All right. Now, and then that's equal to the derivative of 0 is 0. Good. And so now I think we could solve for db over dy, right? db over dy times, let's see, if we factor that out, that takes care of that term. Oops, y squared is there. Where's my other term? Minus cxy. Okay, and then I'll put everything else on the other side. Minus 2b squared y, that takes care of that one. And then plus bcx, that takes care of that guy. Good, and then just divide. So db over dy would be minus 2b squared y plus bcx divided by minus 2b y squared minus cx y. Good. Okay, so this is just kind of playing games with notation, but I think the notation is important. It's good to be able to do that if you need to. All right. Let's see, maybe we'll do one more example just to be sure everything is working okay here. So let's suppose I've got example, I've got x squared plus 2xy minus y squared plus x equals 2. Find the equation of the tangent line at the point 1, 2. Good. So first we should verify that the point 1, 2 is on the graph of this, which means that if you plug in x equals 1 and y equals 2, you should get a true statement. So let's see if that's true. Is 1, 2 on the graph? Just to double check. 1 squared plus 2 times 1 times 2 minus 2 squared plus 2. What is that going to be equal to? Let's see, that's going to be 1 plus 4 minus 4 plus 2. Oops. Did you notice I'm pausing there because it's not working out correctly? That's because I put in a 2 for x instead of a 1. Okay, there we go. That would have tripped me up. Good. Now we get the right answer. That equals to 2. Good. All right, so now we can differentiate our equation to get dy over dx. Okay, and this is the slope, right? Once we evaluate at 1, 2. So let's go ahead and differentiate 2x plus, now we have to use the product rule on 2xy. So that's going to be 2y plus 2xy prime minus, now I'm going to use the chain rule on y squared, 2y y prime, plus the derivative of x is 1 and the derivative of 2 is 0. Good. Now, before we solve for y prime, since I'm evaluating this at a point, let's go ahead and just numerically plug in our numbers. So this is going to be 2, if I can plug them all in correctly. This will be 2 times 2 is 4, plus 2 times 1 is 2, y prime, minus 2 times y is 4, y prime, plus 1 equals 0. Good. And now we can a little bit more easily compute this. 6 and 1 is 7, so y prime, minus 2y prime is going to be minus 7, it looks like. So y prime is 7/2. Good, so now we have our slope and our point. So the tangent line right, will be y minus 2 equals 7 halves times x minus 1. Excellent. All right. Now, the next thing I wanted to talk about is just the, so next, the relationship between the derivative of f of x and its inverse, f inverse of x. Good. So that's going to be in the next video.